Good evening, everyone. Thank you so much for joining us for tonight's webinar, Inquiry Across the Ages, a panel webinar. We're going to be joined by three awesome educators today to share a little bit about their experience doing inquiry in the classroom. My name is Kelly, and I'm so glad to have you here on this late winter day. It's been sunny here in Ithaca, and I feel like spring is just around the corner, and I'm looking forward to it. A heads up that this webinar is being recorded, so don't feel like you got to scribble to take notes. We will post the recording on our YouTube channel later this week, and since you're registered for this webinar, you will get an email with a link to that, as well as the resources mentioned today. So we're probably feeling all very familiar with Zoom these days, but in case you've been using a different platform, I just want to give you a little orientation. When I shared my screen with you, it likely went full screen for you. I'm actually going to recommend that you exit full screen. You can find the options button at the top of your window. Hitting escape might also work for you. And that's because it'll allow you to dock the chat window to the side, and you can participate in any conversations that we have tonight. So to turn on your chat window, you're going to look for the little speech bubble icon that says chat. Click on that. And then over here, right above the area where you text, it's going to say to. Make sure that you switch it to say to everyone so that we can see each other's conversations and ideas and links if those are shared. So let's practice our chat window skills, and go ahead in the chat window, let us know where you're from and what your role is as an educator. Ooh, awesome. We are joined by educators from Oneida, New York, Quebec, Syracuse. Oh, our friend Kathy Wrigling's here. Hello, Kathy. Kathy's been a panelist on this webinar before. Virginia Beach, Binghamton. Awesome. I'm also seeing environmental educators, school librarians, biology teachers. Awesome. Homeschoolers, welcome. This is wonderful. Great range of people. Some people in Georgia and Florida whose weather I'm jealous of. Awesome. We've got a really great mix of educators today. Thank you so much for joining us. Please feel free to keep sharing in the chat window as we go on. So I'm coming to you from the Cornell Lab of Ornithology, where our mission is to interpret and conserve the Earth's biological diversity through research, education, and citizen science focused on birds. The lab does not look quite so luscious and green currently. We've still got several inches of snow on the ground, but it's also a beautiful view this time of year. And as I mentioned, my name is Kelly Schaefer. I'm the outreach coordinator with the K-12 education team, and I'm joined by Susan Licker in the chat window today. She will be there to share some links for you, answer some questions, flag me down if I miss something, and keep us all in line together. And our mission on the K-12 education team is to create innovative resources and trainings that build science skills while inspiring young people to connect to local habitats, explore biodiversity, and engage in citizen science projects. And we achieve our mission really in kind of two different ways. We create all sorts of curricula and resources, from simple activities like bird bingo and scavenger hunts, all the way up to full science units like our eBird Explorers curriculum suite and investigating evidence, which we'll talk about some today. And then we also provide the educator training to support the use of these materials and make sure that everybody feels really prepared to go out and get kids inspired about exploring nature and science. We do those trainings both online and in person. We're very excited to be doing a scaled down, but at least in-person training this summer, which we will be announcing soon, I hope. And all of our resources and trainings kind of focus on these three pillars that you see here: nature connection, citizen science, and inquiry. And you can look at them in a number of different ways. A lot of educators come to us because they're really interested in getting their kids outside. And why not combine that with authentic science exploration? We also view it as somewhat of a pathway, right? Like, you get inspired to get outside and explore nature. While you're out there, curious questions just naturally arise. If you've ever been out exploring with kids, you know they ask way more questions than you can hope to answer, which is super fun. And that's where today's topic, inquiry, comes in. We can capture some of those curious questions and turn them into investigations and use our science skills in really authentic ways. So our goal is really to take kids from a conception of science like this. So if you ask a student to draw a scientist, this is usually something along the lines of what you get: the white lab coat, the beaker and chemicals, equations on the board. Usually there's some sort of crazy hair. In this case, there's an awesome mustache. And this is science, right? For sure, it's science, but it's kind of a narrow conception of science. And we want to help kids broaden their idea of what science is and who are scientists. So we want them to start to see folks like these as scientists, people who are outside asking questions about the way the natural world works, designing experiments, following protocols, and trying to get to the heart of those questions, find some answers for us. All the way to this, to viewing themselves as scientists with skills that allow them to collect data, to think critically, to create graphs and explore the world around them in a structured way. And that structure in the case of science can be really exciting, especially in the case of inquiry projects. So I've thrown around the word inquiry a lot already tonight. Let's kind of arrive at a definition for what inquiry is. In this case, inquiry, when working with students, can be asking and answering their own questions. It's that authentic piece. For us as educators, sometimes it means letting go of control a little bit, and that can be both intimidating and rewarding. It includes things like these project-based learning ideas, right? Where you are bringing in all of the skills that you've been learning and using them to answer one question, exploring one project. And what you'll find when you dive into the inquiry process is that it really helps you meet all of these science practices in NGSS. Things like asking questions and defining problems, planning and carrying out investigations, analyzing and interpreting data, engaging in argument from evidence. So when we're doing inquiry projects, we're hitting all of these science practices in a really fun and integrated way. There are all sorts of different types of inquiry. I know when I was in school, I feel like I experienced more of the confirmation and structured inquiry types. So confirmation inquiry is where you know what the results are going to be, and you're basically doing an experiment that proves a principle that you already know the results of. So think of dropping a ball to demonstrate gravity. That's a super simple one, but you're confirming an idea that's already known. Structured inquiry has students investigating a question that the educator presents, and with a protocol that's also presented by the educator. So those kind of 2 points of what is our question, how are we going to do it? Both of those are provided by the educator. And then we get to guided inquiry, which opens things up a little bit, where students are investigating a teacher presented question, but they get to design or create the protocols that they're going to use to answer that question. And then finally, open inquiry, where students are the ones defining the question as well. So both those points, the question and the procedures, are created by the students or designed by the students. And so the further along you get in this inquiry practices, or excuse me, these types of inquiry, the more opportunity there is for students to use their skills. There's a time and place for every single kind of inquiry on this list, but when we strive for guided or open inquiry, we're creating more opportunities for our students to use their critical thinking skills and develop their science practices. So there are a couple different ways that you can approach inquiry investigations. You can do observational studies, you can do experimental studies, and they have several things in common. You're going to be collecting data, you're going to be trying to answer your question by analyzing that data and sharing your findings. You'll notice that this looks kind of like the scientific method, that kind of linear method that most of us were taught in school. But when you engage in this open inquiry practices with your students, you kind of start to create an opportunity to see the science process as a more integrated and iterative process. So you'll notice on this diagram or image of the science process that there's a lot more interplay between these different steps. You might design an experiment and then realize you need more information, so you go back to look at more references. There's all these ways that these pieces and parts of the science process interact. But broadly, we can call them investigations. When we're thinking about nature-focused inquiry, we're providing our kids the chance to investigate something about nature. And we do have a free resource available if you're interested in doing inquiry with your students. Investigating evidence is going to provide you a framework to work within. It is has been used in classrooms from K all the way to community college. So there's some adapting that needs to happen in some of those ranges. I would say the sweet spot is probably 3rd through 8th grade. For this, but you can use it in all sorts of different age groups. And we are currently working on a pretty exciting project to rework this curriculum into a K through 5 and 6 through 12 version. But right now, Investigating Evidence is a free download available on our website, and it's going to help you scaffold the process of inquiry, including providing a timeline of where these different parts are going to happen and how to plan for doing inquiry in your classroom. And one more thing I wanted to share with you before we hand it over to our wonderful panelists is the Scigirls Strategy. So Scigirls is a public television program run out of the Twin Cities in Minnesota, and they have put together these awesome research-driven strategies for engaging girls in STEM. Most of you are probably aware that there is a bit of a STEM gap that begins to happen for girls at a pretty young age. And it's not that girls don't have the same capacity as boys to do STEM. We see that their test results are the same. It's just that there's some sort of interest gap, or even like girls just don't see themselves as scientists. And so these strategies can help reduce those gaps, with the added benefit that they don't discourage boys from doing it. They work for all genders, and they provide some opportunities too for incorporating culturally responsive education, which is going to work for folks of different backgrounds too. So some of those are connecting STEM experiences to girls' lives, supporting girls as they investigate questions and solve problems, empowering girls to embrace struggle, overcome challenges, and increase self-confidence. And a lot of these ones that you'll see, you can really incorporate into inquiry practices, inquiry investigations that you do in your classroom. You're providing opportunities for collaboration. You're providing an opportunity to create something that they feels relevant to themselves because they had the opportunity to make up the question, make up the procedures, and you can support them as they go through that process, which can be a challenging process and it can be really rewarding to work through. So I feel like inquiry is an awesome way to incorporate some of these strategies into your practice as well and help feel girls more empowered to participate in STEM. And with that, I am going to invite our first presenter, Channa, to take the stage and tell us a little bit about her experience using inquiry with students. Channa, please unmute and I will be your slide person. So just let me know when you want me to move on.
Awesome. Thank you so much, Kelly. Hi, everyone. It's so exciting to be here. And thank you to Kelly and the team at the Lab of O K-12 Education Department for inviting me to this webinar tonight. And I'm just going to share briefly a little bit about my experience with inquiry. I am a STEM educator. I also have I worked with students from preschool to adults, and inquiry can be used for all of those age groups. Kelly, can you go to the next slide, please? And so it works for all ages, right? And so we know that the primary focus of inquiry is to develop skills with our students that they are going to need for their future careers, whatever those careers are. They need to be able to question things. They need to be able to research. They need to be able to talk about what they're learning and what they're finding to a broad range of audience members, whether it's someone in the public, whether it's someone in their field, whether it's a layperson, experts. They need to be able to communicate in different ways to different people. They also need to be able to work together, like the days of being siloed and working alone are over. They need to be able to solve problems, especially going forward. We have lots of problems that need to be solved in our environment, in our world, in our society, and they need to have the skills to be able to develop and create solutions to solve those problems and really to tackle real life issues and questions. So through inquiry, we can actually give them some practice at doing that, even at any age, as young as they are, all the way up to high school. So this is a process that can be applied to any group of students. They also need to be able to participate, right, in the creation and improvement of ideas and knowledge. So as they learn and they share their learning, the knowledge base grows, which can then help future generations to do the problem solving and the creation that needs to happen. And what I have found in working with students, whatever students you're working with, is that the more place-based and relevant you can make your activities, the best, right? So if you're out in nature, go to the local park, go to their local environment where they live so that they can think about how they could potentially have some impact in their own communities. So place-based and relevant is always best for engagement, and also to give students an idea of the power of what it is that they're doing. Next slide, please, Kelly. And so I just have a few points about what well-designed inquiry is. I think that a well-designed inquiry process places the learners at the center. So the teacher, the resources, the technology are all organized there to support them, but the primary focus is the students and the learners, and they're driving what's happening in the process. The activities are also primarily revolving around information processing and not so much facts and memorization. Teacher is a facilitator, that old adage of not the sage on the stage, right? You're facilitating the learning process, but teachers are also learners in this process as well, because one group of learners is going to be very different from another. And every time you go through the inquiry process with a group of students or a group of learners, you're going to learn more about the process, what works, what doesn't work, how to scaffold different ideas for you to tailor it to the audience that you're working with. And then finally, the emphasis should be on evaluating the development of the information processing skills. So really the focus is on the skills that their students are developing, and how do you evaluate whether they're learning. It's very interesting in switching the thought process from more traditional science instruction or STEM instruction to inquiry based, because really it could be any content. You can do it with any content area. You're really focusing on the process. So the facts that they're learning and the content they're learning is actually secondary to the process and them learning the process. Once they learn the process, they can apply it to anything. And even outside of science, it can be applied, right? So it's really just teaching students how to critically think, how to evaluate, how to collect evidence, how to communicate about that evidence and their findings. Next slide, please, Kelly. And so Kelly talked a lot already in detail about the different stages of inquiry. I like to look at it as a ladder, and you want to start with wherever your learners are. Different groups of students are going to be at different stages based on their experience and their background in science or STEM, and you have to meet them where they are. And if it means starting at confirmation inquiry and working your way up gradually up the ladder with various scaffolds and introducing it to them in a way that there's still what I call productive struggle, but at the same time, they are not so much that they're frustrated. Next slide, please. And just about my own experience, it can be used in multiple contexts. I don't know what happened to that slide, but there were a couple of pictures there that are not there. And I just wanted to talk a little bit about my own personal experience as an educator in using inquiry in different contexts. One of those is working with students who were in high school. So I taught high school, and I did an inquiry project where I took a group of high school students, they were 10th graders, out into a local park in the Bronx. I teach in New York City, and I don't have photos of them. Unfortunately, I didn't have it on my current computer, but they were out, and I created stations for the students, and I did it in collaboration with other organizations. So it was a big project. I had help from a variety of organizations in the community, and we were able to get waiters. We were able to get material so that we could do different stations in the park. So they went into the Bronx River, a portion of the Bronx River, and they collected macroinvertebrates. They went to a portion of the forest or the park where there were some fallen trees, and they got to do observations to create an investigation about what they found in the fallen trees. They also did like a leaf, what was underneath the fallen leaves on the ground. They were able to do worm raising. They did a variety of different activities to explore their own local community. And through those observations, they were able to develop their own questions for investigation and then take them further. And we actually did a little bit of a twist on it because we couldn't go outside multiple times. So what we did was we looked at their observations and their questions, and we were able to convert some of those things into experiments that could be done in a controlled setting, a controlled investigation in the classroom. So they were able to take what they learned outside and bring it back to the classroom and still continue to learn the scientific process. Another way that I have applied it, and it's not in a life sciences context, it's actually in a physics context, in a physical science. It is where students were able to design their own, it was through a design challenge, which is a different type of inquiry, but these students were able to use a very familiar activity, which is an egg drop activity, but this time they were able to use it to develop a device that would protect a football player's brain from a traumatic brain injury. And that's actually a video that if you're interested, you can find that video on the teaching channel, and you can see how the students worked together, collaborated to design and test their own solutions to problems. And then finally, I want to talk about the work that I did as a coach. I worked with preschool teachers, and we actually designed an inquiry process for preschoolers. So when I say any age, I mean any age. You can tailor it to meet your audience's needs. And so this was an activity that happened in the school building, and the students did a whole investigation about water. And that's the picture on the right. There were multiple stations where students were learning about different concepts related to water through their exploration. And while they were doing that, the teachers were actually doing observations of the students and taking notes for themselves for their own learning, so that they could go back and really look to see what the students were learning, what kind of questions the students were asking, the comments that they were making, so that they could continue to stretch their practice. So that's it for my presentation as far as my experience with inquiry and my rationale for using it. And I look forward to hearing your questions at the end of the presentations. Thank you.
Thank you so much, Channa. I really loved your latter example of meeting students where they are on the inquiry process. What a great way to think of it. Also, productive struggle sticks in my mind, and I might ask you a question about that in the Q&A section. All right, thank you so much, Channa. And now I would like to invite a longtime friend of the program, Terry Wilson, to share a little bit about her experience.
There we go. Good evening, everyone. I'm Terry Wilson, and I'm thrilled to be here. I can't ask for coming behind two amazing educators. I feel like they set such a wonderful foundation for the inquiry process. And what I'm going to speak to is really my experiences in my own school, which is located in Connecticut. We're just a little bit southeast of the capital, Hartford. It is very cold here. Our snow has kind of melted, but we're just really, really cold. But with the big full moon tonight, everything looks just wonderful. So next slide, please, Kelly. Thank you. So I have several roles that I play at my school. I'm a science coach, which means that I support my pre-K-5 teachers in the implementation of our science curriculum. And I also, this year, am a science specialist, where I am actually seeing every single student in the school from pre-K through 5. That's approximately 470 students, and I see them once a week, and we work on various projects. As you can see by this picture, these pictures, I should say, we have a lot of opportunity to bring science outside, and the Bird Sleuth Investigating Evidence curriculum truly is a foundational resource that I've used when bringing my students outside. In these pictures, you see kids planting. We run with the Journey North program, which is a citizen science program where our first graders plant tulips, and we look at plant phenology, and they're able to upload their data, their observations, to the Journey North site, where they look for evidence of how our seasons are changing, and through the plant growth, I should say. And we're always excited. We always try to predict when are we going to see the first buds of our first emergence, I should say, of our tulips. And Mother Nature always throws some curveballs at us in Connecticut. We also, with my kindergartners, we explore seasonal changes by choosing a class tree. And they observe each of those trees throughout the seasons. And we talk about the changes and make predictions, and the students pose questions about the trees. And we're really able to utilize the outdoors and looking at those changes to help answer their questions. Next slide, please. So this past year, we were so blessed that with the Connecticut Audubon Society, we received a substantial grant. And this was geared for my 4th grade students. We learned traditionally about the Connecticut River watershed, and to expand on that, we developed a rain garden, and we looked at other types of gardening around our property. We also developed composting. If you've never done that, it is an amazing experience. Again, this was something where I sort of brought the problem to our kiddos. My school grounds were very sterile. And what you're seeing there is gardens that sort of have been tended to, but for the pretty much have been able to run wild. On the far right, you can see our outdoor compost bins. And we are trying to utilize, or that's the next step that we're going to be doing, is really getting those outdoor compost bins running. But again, it's all based on a problem that we had of having very sterile grounds and what we could do to improve upon those grounds so that we could use them for stronger learning connections. Next slide, please. So the problem was where on our school grounds should our school be placed? So they looked at the Connecticut Valley, the watershed. They looked for the surrounding areas. We went from literally a bird's eye view of our location and then zoomed in to the features of our school and where the needs of our plant life that we were interested in, and we were looking at native pollinators, where would it be best? So the students were able to utilize like Google Maps and such. Next slide, please. Thank you, Kelly. So after doing all their research, we looked at the school grounds, we looked at water runoff, water sources, and the hours of daylight. And where you see the little green star, that is where we chose to put our garden. However, we ran into a snag. My building is run by the town of Glastonbury, but my school is managed by a magnet system called the Capital Region Education Council. Well, unfortunately, the Glastonbury town groundskeepers did not want us to put a garden where we had located the best environment for it. So that was kind of a political snag we ran into, and the kids learned about how to work within the system. So if you look a little to your left on that screen from the star, and you'll see a little bit of a outcropping half circle, we actually ended up a little lower. Yeah, right there, right there. That is where we ended up putting our garden. So it still had the daylight hours. It still had the amount of exposure or I should say the depth of exposure that we wanted for our native plant pollinators. It was a little disappointing because we wanted a pond in our garden, but that just didn't happen. We're working on that though. Next slide, please, Kelly. So to pull in some of the other grade levels, we had our kindergartners keep data about what kind of birds they observed at their feeders, which were these wonderful feeders we got from Cornell. And they were looking at the types of birds. So we, as you could see, we had some cardinals, the robin, and a sparrow, I want to say. I hope I had that right, Kelly. My birding is off a little bit here. And then based on this data, we had the fourth graders decide on which native plants to use to bring in those native birds and insects to our garden. Next slide, please, Kelly. And I'm sorry, that was it. So I look forward to hearing your questions, and thank you so very much for allowing me to be a part of this event.
Thank you so much, Terry. Your birding was perfect. It is indeed a sparrow.
Thank you.
I also really love how you're incorporating different age groups and different grades into this awesome outdoor space you're creating. That's great. Thank you so much, Terry. All right, now I'd like to invite our friend Phil to take the stage and tell us a little bit about his experiences using inquiry as well.
All right, can you hear me okay?
You sound great, Phil.
Awesome. I'm using a new headset and I've never used it before, so this is way cool. I'm at a new school this year, and so this is going to be a kind of a walk through memory lane, and then I'll tell you what's in the works at my new school. But this was a bird blind that we were able to build just west of Portland, Oregon, in Hillsboro, Oregon. And we decided to build a covered bird blind with a bird feeding station out front. And this way we could go outside and watch birds, rain or shine. Next slide. And there's a look from it from the outside. And so we could walk, we had a green space behind the school, and we could walk across the ball field, and it crossed a stream. And there we were, with the bird blind and the bird feeders. Next. And so having a feeding station at school allows for lots of inexpensive mini field trips right on the campus. I knew right away when I first started teaching, I wanted my students to get outside, and so that was a major goal, and one of the reasons that we established this. And while doing that, over the years, students would get outside and begin to appreciate nature, and they really loved going out there. And we got them using the scientific method, and really the inquiry, investigating evidence, was a backbone of my science program there. Next. And each of my students, we would get them hooked on eBird, and each of them had their own eBird account. And they were quite excited when they learned that their data would be used by real scientists. And then, of course, they got to use it themselves. Each of them would write up a report. They would do their own investigation. Again, we used the templates in investigating evidence. Next. And we usually began at the beginning of the year learning how to identify birds, looking at field marks, and then we would go over protocols, how to count species, making sure we didn't count the same bird twice. Next. And so we developed a tally sheet. I kind of customized this. I think I originally got it from some materials from Bird Sleuth, but anyway, I added weather data, and so using bird data and weather data, students could get could look at both an independent and a dependent variable, and we were looking at how different weather factors would affect the number of birds. And so students had, a whole menu of things that they could choose from. And we had a weather bug station on top of the school. And so we could get real-time weather data from that weather station before we went outside to watch the birds. And so students could track, how did temperature affect juncos over a period of time, or how did wind speed or time of day or rain affect total birds? And so that gave them a rich selection of independent variables. And then of course they choose their dependent variable to look at cause and effect. Next. And so I was there for quite a while. That's like, I don't know, over 20 years worth of data. And when we first started the bird blind in 1996, our most abundant bird species were dark-eyed juncos. And we had never observed a house sparrow coming to the feeders. And then a few years later, around 99, 2000, that all changed. There was a construction project near the school. Originally, the school was fairly rural, and then there were apartment buildings that went up behind the school, and an Albertsons shopping center across the street from the school, which took away the filbert orchard. And so drastic change in habitat. And all of a sudden we were seeing house sparrows, and the junco population started to decline. And my students noticed between those 2 years, because it was quite drastic. And then, over the years, they kind of went up and down. And I'm not sure why we had such a spike in house sparrows, and then that kind of moderated. But it is kind of interesting to see. Next. So here is aerial photos showing before and after the habitat loss, the construction. So the black and white photo on the left shows the yellow star is approximate location for our bird feeding station. And you can see a fallow field if you look to the top there above the star, it's kind of a fallow field. Yeah. And then of course, across the street from the school was a filbert orchard. Well, in the color photo on the right, you can now see a housing development behind the school. The green space was still there where our bird blind was with the yellow star. Then there was, of course, the shopping center and more houses then across the street from the school. And our school also expanded. But it is interesting to see habitat change. And so my students kind of wondered if that was part of what changed the populations of juncos and house sparrows. Next. And so Christina, one of my 10th grade students, decided she wanted to write her research report about those changes. And so she researched what was happening with dark-eyed juncos in Oregon to see if anybody else was experiencing a drop in junco population while house sparrows were increasing. And if I remember correctly, she did not see a significant difference in other locations in Oregon, which led to her conclusion that that the housing development most probably was the cause. And so she was published by one of the predecessor papers for the bird sleuth investigator. Sorry, my mind is it's the end of the day. So this was published, and this was so cool because students can get published with the bird sleuth investigator now, and it's really a cool opportunity for students. Next. And so another student of mine followed up, one of my 7th grade students, Nick, also wrote about the effect of urban development on house sparrow populations. And he noticed that, of course, the house sparrow populations had gone up over time. And so he also thought that that it was construction and the change in the habitat. So anyway, it's a really cool opportunity. Many many of my students, or many students can do inquiry, but the opportunity to be published is rare. And so this is a really cool opportunity for students to get published. Next. And so Bird Sleuth Investigator provides this opportunity. So it's pretty fun. You can also, students can submit their artwork. Several of my students had their art published, and younger students have had other types of things published as well, poems, and Kelly can probably tell us more. This last article, I had a couple of students collaborate together, and they looked at how temperature affected Steller's jays and whether or not Steller's jays were present. Next. And okay, this looks, oh, this is total bird population trends, which is for the 20 plus years that I was there. And it is kind of interesting to look at total birds and total species, and total numbers of birds in the blue line over that period of time kind of went up and down, and then it just sort of seemed to got less and less, while species, the number of species got greater. And I kind of attribute to that that I was getting better at identifying species and seeing them and noticing them. So that probably shows my growth more than anything. Because before that, I'd have to let species go if I didn't know what they were. But it just seemed like overall numbers were declining, and which is also kind of interesting because I think that kind of mirrors some of the other data that has been published in recent years about bird populations declining. Next. Oh yes, and so this new curriculum package, I believe this is just now becoming available. It's been in the works for a couple of years. But if you want to use and look at the data that my students collected over that 20 plus years, I think one of the last lessons in the high school curriculum of eBird Explorers, all that data is available to you. And so your students can play with that data and explore it and draw their own conclusions. All right, I think that concludes my part of the presentation. So I'm ready for questions.
Awesome. Thanks so much, Phil. I just wanted to real quick go back and, oops, that's the wrong way. Is this drop right around here when the construction was happening?
I believe so. Yeah, that was right there where the construction was going on. Yes.
It's interesting to see your data capture the effect in so many different ways.
Yeah, it is cool. And it leads to lots of questions, doesn't it?
It does. What a cool resource to have a long period of data. Awesome.
Yeah.
So we have our three wonderful panelists here, and I'd like to open it up to questions from the audience. If anybody has questions for our panelists, feel free to share them in the chat window. And Susan, I don't know if you've had any go by as we've been going that I might have missed in the chat window.
Yes, there is one asking if all of the teachers who were speaking tonight had used investigating evidence for the specific projects that they were talking about.
Well, I certainly used investigating evidence. That was the backbone of my whole curriculum on inquiry, using the bird feeding station I had.
I definitely used it for the development of the garden project.
This is Channa. The activities that I talked about that I've done with my students actually predated my introduction to the Cornell Lab. So I have since gotten to know the folks at the lab and have used investigating evidence. I was all set, and I have used components of investigating evidence because it's not just about birds, or just about, it's actually the whole process of learning how to get students engaged and how to get them questioning, wondering how to use data, collecting data. So it's an invaluable resource for all of those parts of the process. So I've used those components, and I was looking forward to actually taking some students out last year to do some birding using eBird and starting to actually do some citizen science with them here in the Bronx, but COVID. And I was told I could not take students out of the building, even if they're fully masked, because of liability. So we're gonna have to wait until I'm able to do that.
Thank you. And I see there's a question in the chat window too. Phil, if you would maybe be willing to share your tally sheet that you created.
Oh, absolutely. Yeah, how's the best way for me to do that?
Yeah, if you send it to me, I'm going to be sending a follow-up email to everybody with a link to the recording, and I could just attach it to that if you're okay with it going to everybody.
Absolutely. Yeah.
Okay, awesome. Great. Let me just check our. Okay, we have a question for everybody saying the ideas are all fantastic. For me, as a public school high school teacher with fairly large numbers of students at one time, 60 to 100 per year, I find it difficult to work in true open inquiry types of activities. Any insights or advice?
I know that I'm an elementary teacher, but considering that I teach 470 kids a year, my suggestion would be, if those 60 to 100 kids are at different grade levels, you might think about the inquiry ladder that was presented, and start where the kids are at and then build those inquiry skills over time. That's just my first gut instinct. Ah, same grade, same.
I have just because I'm in New York City, which is as you guys know, is the largest public school system in the country, and it's a challenge, and on many levels. So it's a challenge because of time, and depending on what curriculum that you're being asked to teach, does it actually fit in with the curriculum that you're using? However, it can be accomplished. The way I did it when I taught in high school, I have anywhere from 4 to 6 classes that I'm teaching each year. Each with approximately 30 students in every class. And so one way to tackle it would be to do an inquiry project with one class at a time, as opposed to trying to do it with the whole grade at once. You can even split it up and do it with a small group of students at a time in a class. So for example, you could split it up into thirds and make it manageable so that you don't need to have other staff members with you to go out with the students. And then you can have the students that are remaining work on some other independent work while you're out with the group that's doing the outside work. And then, sort of rotate them that way, so that they could all get the experience, but then inside working on the other aspects that don't require them to be out of doors. So that is one suggestion that I would have for managing the number of people, if you're able to figure out how it fits within your curriculum. I would just chunk it, as far as the students go, chunk the students into groups, manageable groups, or if you can recruit other people to work with you. So when I did my high school project, I actually had volunteers coming from the organizations that were supporting me. So I had the Bronx River Alliance. They sent a person as well as giving us materials. So I had various organizations send people as well as teachers. So I was able to manage all the different stations, the different students in different areas of the park, and still have enough staffing and enough people with the expertise for some of those stations, and then also just to manage the bodies. So I hope that's helpful.
Awesome. Thank you, Channa.
I'm thinking I probably did something similar with just dividing groups up. I mean, I was fortunate. I usually did not have a classroom of more than 30 students at a time. and my bird blind would fit 30. It was cramped. But we would go out and collect data, you know, for 15, 20 minutes, maybe once a week, sometimes twice a week. And then we'd go back to whatever else we were studying. And so I just sort of chunked it up like that and spread it out over time because I wanted my students to have plenty of data. And so that's the way I managed it. But I was lucky. I was at a small school and didn't have the numbers. But I am now teaching at a public school. It's kind of a different type of scenario where we're kind of in an urban setting, and we don't have a natural green space behind our school. And so I'm working with my principal right now. He lives right next to a green space, and we're thinking about building a bird blind on his property and then putting up webcams on the feeders. I'll let you know what happens, but since all my students have Chromebooks, we hopefully can dial into the bird feeder cam at his house and collect data that way, but we'll see.
That's a cool idea. If you ever have questions about setting up bird cams or live cams, similar to what Phil's describing, definitely reach out to us and we can hook you up with the bird cams folks, and they have some good suggestions.
Awesome.
Yeah, I'm really
I may be
excited to hear
calling.
that.
Send me an email. I'll hook you up, Phil. That goes for anybody
Excellent.
else as well. Awesome. So I also had a couple questions prepared that I want to throw out to you guys. For me, thinking about tackling inquiry for the first time, it feels kind of overwhelming. So I'm wondering if there is like something that you wish someone had told you before you started diving into inquiry with your students.
Oh my goodness. I think the biggest thing is just start. I wish I'd started sooner. But it took me a while to, you know, take that deep dive, but I'm glad I did. And I learned as I went. And I'm still learning. And of course, the investigating evidence really organized things. And so if you start with that and it's a free download, you've got the tools there you need to, and you will grow with it. I would just say start small and just keep building.
Awesome, thank you.
That's definitely sage advice, Phil. You took the words right out of my mouth. I agree completely. And you know what? The other piece is you don't have to know all the answers. All right, you need to be vulnerable with your students and say, you know, I don't know that. Let's figure out how could we find out more, or how do you think we might approach it, and take it from that perspective, as you are a learner just as much as they are.
I would say, if any of what is one thing that I wish someone told me, how challenging it is, particularly I'm also in an urban environment, public school urban environment, where on average our students are 2 grades below their grade level in terms of their literacy, which makes teaching any kind of science activities difficult because of the language, the vocabulary, and because there is no mandated curriculum for elementary school. Students come into science at all different levels, depending on the comfort level of the teacher that they had in elementary school when they come to middle school. And so there's a variety of challenges, and the biggest challenge is really getting students to come up with questions. So that's something that I didn't think that would be a problem, but I actually had to learn how to help students come up with questions.
Yeah, there's a difference between a curious question and a testable question.
Yeah. And there's where investigating evidence helps you out.
You took the words right out of my mouth, Terry. That's exactly what I was going to say.
Yep. Yeah, that's covered well in the curriculum.
And
All right,
we had one more question in the chat asking if Channa could elaborate on the ladder of inquiry.
Yes. Yes.
And give examples.
Yes. Am I muted? Am I muted? No.
You're not muted. You're good.
Great. So for example, the confirmation inquiry is just a standard, right? You know the question, you give them the method, it's just step by step. You already know what's going to happen at the end, right? And the students are just basically confirming what you already know is going to happen. So this is the easiest part. And this is pretty much every cookie cutter science activity that's out there. So that's, if your students don't have any experience with inquiry, of course, that's where you'll start, right? The next level, structured inquiry, is where you give them the question and you tell them how they're going to get the result. And you know that the explanation, what's going to happen, but they're actually discovering it through the process of experimentation or investigation, right? So they're gathering the evidence, they're really doing some of the work, more of the work than they were with the confirmation inquiry, but it's still heavily guided, right? It's heavily structured because the question is given to them. I'm trying to think of an example that I've used that is structured inquiry. I would say some of my design activities have been structured inquiry because I give them a little bit of the information and and I know the answer, and they're basically just getting to it on their own. It's almost like leading your students to the correct answer, but giving them a little bit more freedom through the investigative process. The guided inquiry is where you only give the student the question. So right now I'm using a curriculum called Amplify Science. And in that one, I give the students a question and they have to go through a series of activities and to be able to answer that question on their own. But depending on how they reach their conclusions, their answers may vary, right? And so they're testing to see whether or not their methods are correct, and more so than they are testing to see whether or not they're going to get the quote unquote right answer. And then open inquiry is just everything. They design the questions, they design their investigation methods, they carry out the process, they present, they do their interpretation of their data, they do the whole thing from start to finish. And so that to me is the most challenging one for students, especially, as I said before, if they're not used to asking questions, that first part can be the most challenging one, getting them out there and actually. And so I teach my students that everything starts with observation, and without observation and without really noticing things at a very deep level, you're not able to ask a question. So I actually start with teaching them and spending a great deal of time teaching them how to do noticings and make noticings about things, and then being able to turn those noticings into questions that they can investigate. So it's really a process, and it really depends on where your students are. But sometimes the observation and the questioning piece will take up a great deal of the time. And so the activity that I spoke about, where I took students out into a local park, actually was two different ones. I kind of conflated them, but it was a middle school activity. We went to the park and I gave the students the opportunity to make observations in the park and then to come back and talk about what questions that they had that could be investigated. So that was more of an open inquiry. And I would say I would start with the most restrictive one, right? The confirmation at the beginning of the school year, and gradually work your way to open. And hopefully by the end of the school year, they can be open and doing full open inquiry. I hope that's helpful. You're welcome.
Thank you, Channa. All right, it is 7:03. So we've come to the end of our time together. If you want to receive a completion letter from us for one contact hour, please email us at k12lab@cornell.edu and we can send that along to you. Also, please feel free, if you come up with questions later, you can email us there as well, and we can reach out to our panelists and see if they have some insight for you. Terry, Channa, Phil, thank you so much for your time and for your expertise and sharing your stories with us.
Thank you for having me.
Yes, this has been awesome.
It was great meeting you, Phil and Terry.
Yes,
Always.
Channa.
Thank you. Same here.
Yeah.
Bye-bye.
All right. If you are here with the New York State Master Teachers, we're going to be opening up a breakout room for you, and you can go ahead and enter there for the rest of your session. Yeah.
We actually can't do breakout rooms because it's a webinar, not a meeting.
Oh,
so they'll just need to stay on. Yes.
All right. If you're here for the New York State Master's Teachers session, please hang in with us. Otherwise, I hope you will consider joining us for a future webinar. Thank you so much for joining us tonight. You can keep an eye on your email for a link to the recording of the webinar, as well as the links we discussed tonight. Take care and have a great week.
All right, thanks, Kelly.